Chapter 4 is basically divided into two parts. Our first part is going to be set theory, and then the second part is evaluating arguments. So it's all part of a greater topic, which is logic. So you're going to see some new symbols and vocabulary that you haven't seen before, probably. So just take some time to learn what those symbols mean, and you're going to be fine. So a set is a collection of distinct objects called elements of the set. A set can be defined by describing the contents or by listing elements of the set enclosed by brackets. So some examples of sets are the set of all even numbers, the set of all books written about travel to Chile, the set of primary colors. That's just a very small set of examples. There are infinitely many sets that you can come up with. Maybe you're even thinking of some on your own. As humans, we love to put things like group things, and that's what set theory is all about. It's grouping different things and deciding which things have what in common. And naturally, humans like to do that. So most people find this stuff kind of satisfying. That doesn't necessarily mean you will, and that's okay. And then we have a subset, which is a set of another set that contains only elements from the set, but may not contain all of them. If B is a subset of A, we write B, and then here is your little symbol for a subset. And then a proper subset is still a subset, but it might not it doesn't have all of the elements of A in it. So we're going to be doing some examples with that. So it's a subset that's not identical to the original set. It contains fewer elements. And then that has its own special symbol. It's kind of like in algebra, how you learned the less than or equal to, or just plain less than. So the first one means that it could be less than or it could be equal. And then the plain old less than symbol just means that it's strictly less than, that it can't be equal to. So it's really the same with this notation, except we make it more like a sideways U. So this is a subset. It could be the same, or it could be less than the original set. And then proper subset, it has to be at least one less element, but they still contain everything that's in the proper subset has to be in the subset itself. So you're looking at all similar elements. So let's look at an example. If A is the numbers basically 2 through 20, but all the even numbers, then determine if each one of these is a subset, proper subset, or neither. So 2, 4, 6 is both. It's a subset and it's a proper subset because it doesn't contain all of the elements of A. 2, 4, 5, 6 is neither because of that 5 in there, which is a little bit sneaky, but there's no 5 in the original set. Oops, I thought I was still highlighting. So we have to say neither. C is the entire set, so it's a subset because every set is a subset of itself, but it's not proper because remember, to be proper, it has to be at least one less element. And then the empty set is also both. It's going to be both for any set because an empty set is always a subset of any other set, and it's proper because it's obviously less. So empty set is both. And I guess I hadn't really talked about empty. Oh, I missed it. Yeah, it's up here. Empty set is denoted either by the curly brackets with nothing in it or like the no smoking sign. But don't put the no smoking sign inside the curly brackets because then it's not empty anymore. And this symbol, this little E thing means is an element of. And then commonly we use a variable to represent a set, and that's what we did down here with A. So I don't know why I skipped all that important information. But good thing we caught it. And then I put it again here. The element is denoted with the symbol. It's kind of like an E. I'll draw it a little bit bigger for you. It's like this. So you draw kind of like the subset sign, and then you put a line in there. So this is saying is an element of, and then we have examples. We have the same set again. Set A is 2 through 20, all the even numbers. Is 5 an element of A? That's what this is saying. I need to change my pen size here. And the answer is no. Is 10 an element of A? Yes. 7, no. 22, no. So hopefully, it takes a little getting used to with that notation. So make yourself flashcards or something just so you can get nice and familiar with it so you don't have to keep looking it up every time you see it.